We've spent the last few years watching massive general-purpose foundation models consume the internet. For most businesses, these horizontal models are deployed for broad applications, powering customer service chatbots, drafting marketing copy, or running basic data analytics. But when you apply them to specialized industry tasks, a severe limitation emerges. They lack specific domain context, requiring enormous amounts of customer-level configuration just to reach baseline utility. We are now seeing a sharp pivot away from these broad applications towards systems built specifically for individual industries, vertical AI. This animated chart illustrates the aggressive trajectory of this shift. We can see the global vertical AI market scaling rapidly from its current baseline, projected to hit exactly $74.5 billion by 2033. As the limits of generalist models become clear, enterprises are prioritizing specialized experts to achieve higher precision and quantifiable financial outcomes. In the boardroom, the conversation has moved past experimental IT budgets. Vertical AI is evaluated on direct financial returns and precise payback periods. In pharmaceuticals, a legacy regulatory submission process takes 10 weeks to prepare. A specialized AI workflow compresses that to 2 weeks. By collapsing cycle times, companies achieve ROI over 100%, paying back initial costs in under a year. The legal sector is seeing similar efficiency gains. Vertical AI platforms like EvenUp target high-cost, repetitive language tasks that drag down billable hours, specifically generating complex demand letters for personal injury claims. By automating those precise legal workflows, a firm drastically reduces the time spent on document preparation, allowing them to take on more cases and directly increase their revenue margins. Financial firms apply this exact logic. Instead of relying on general models for standard fraud monitoring or basic anomaly detection, they are deploying advanced models tuned directly to complex regulatory environments. This data table tracks the impact of these vertical applications. When implementing tools like automated underwriting and intelligent credit scoring, underwriting costs drop by 90%, while overall return on investment jumps by 150%. Across sectors, vertical AI takes artificial intelligence out of the theoretical realm and turns it into a defined, predictable cash flow generator. How do these vertical systems achieve this level of accuracy and return on investment compared to massive general models? This node-based graphic represents the foundation of a vertical system, a domain knowledge graph. Instead of basic wrappers, they preload the AI with specific industry logic. The system innately maps how a supply chain failure links to an asset, or how beneficial ownership connects across entities. When you train a specialized, fine-tuned model on this deeply structured data, it consistently outperforms massive zero-shot foundation models in domain accuracy. Recent technical benchmarks reinforce this gap. Whether analyzing complex agricultural yield data or evaluating specialized face recognition datasets, domain-specific models reliably beat general-purpose models in precision and low false match rates. The most effective enterprise tools are utilizing a technique called model fusion, bringing both approaches together in a dual architecture. The vertical model generates a highly accurate answer grounded in domain-specific logic. The foundation model then translates that result into clear, human-explainable text. An AI's true expertise is not determined by the sheer volume of its training data. It is determined by how closely its architecture aligns with specific industry logic. As these highly tuned models become standard, the nature of enterprise software is shifting. AI operates as an embedded, autonomous agent that executes the core workflow. This deep integration establishes measurable financial outcomes as the primary metric of software value. This introduces a critical strategic concept for the enterprise, the defensible data moat. In previous eras of enterprise technology, a company's competitive defense was the software code and the platform architecture itself. Today, the structural advantage belongs to whoever controls the deep, proprietary, domain-specific data used to continually train and refine these specialized models. That realization is driving a massive surge in global mergers and acquisitions, alongside heavy venture capital deployment. Strategic acquirers are currently buying companies to secure proprietary datasets and AI maturity. prioritizing data assets over simple user bases. Companies that adopt vertical AI and build aggressive data moats are positioning themselves to capture disproportionate market value. Those relying on broad general-purpose tools risk being permanently outmaneuvered by hyper-specialized competitors.